Hello, my darlings. Okay, so today we're going to look at solving systems of equations using matrices. Now, I have an example here. It's two linear equations that we want to solve algebraically. I know you know how to solve systems either by substitution or elimination, and I know you also know how to solve them graphically. So we're going to choose one of those methods, and since the directions say algebraically, we need to use substitution or elimination. You could solve that top equation very easily for either y or x and then do substitution, or I'm going to use the elimination method, and I'm going to try to eliminate the y variable. So I'm going to multiply the top equation by -3. Okay? So if I multiply that top equation by -3, I'm going to have -3x minus 3y equals -9. And I'm going to bring over that second equation, 2x plus 3y equals 8. Now, when I add the two equations, I'll have -x, the y's add to 0, they have been eliminated, equals -9 plus 1 is -1, which means x is positive 1. If x is -1, then positive x is positive 1. Awesome. Now, we can take the fact that we know that x plus y equals 3, and we know that x equals 1. So we substitute the 1 in for x, plus y equals 3. And if we subtract 1 from both sides, we find that y equals 2, which means that our solution is the point 1, 2. And there we go. We have solved the system of equations. Now, I'm going to do something that looks totally unrelated, but there is a method to my madness. The next thing I want to do is I want to find the inverse of this 2 by 2 matrix. So to find an inverse, remember we start by finding the determinant of the matrix. So on this diagonal, 1 times 3 is 3, minus on this diagonal, 2 times 1 is 2, and when we subtract, we get 1. Which means that for our inverse, we're going to have 1 over the determinant 1 times, on this diagonal, we switch the numbers, and on this diagonal, we negate the numbers. And since we're only multiplying by the scalar 1, we have the matrix 3, -2, -1, 1, and this is our inverse matrix. Okay, now I'd like to multiply the two matrices below. So remember, from the first matrix, we're going to take the rows, that would be the 1, 1, and the 2, 3. And from the second matrix, we take the column, and there's only one column. So when we multiply here, put it equals, we open up our matrix. In the top left, we are in row 1, so we take row 1 from the first matrix. That's going to be 1 times something plus 1 times something. Now the somethings come from the column. We're in column 1, so we're going to take the x and the y. When we move down, we're in row 2, so now we have 2 times something plus 3 times something. And that something would be the column x, y. Now if I try to move down, I'm out of rows, so I can close this off at the bottom. And if I move back to the top, I notice, I don't have any more columns, so my matrix is done. Now if I simplify that in there, 1 times x is x, plus 1 times y is y, and in the bottom, we're going to have 2x plus 3y. Now this matrix might look slightly familiar. Not exactly the same, but slightly familiar. I want to go back to that system of equations that we solved in the first problem. Only this time we're going to solve the system of equations using matrix equations. So this is where I'm going to teach you a new method. Now remember when I said something might look familiar? See this part of the equation? It looks an awful lot like what we had in example 3. In example 3, we had that 1, 2, 1, 3 times the matrix x, y, right? That gave us the matrix x plus y, 2x plus 3y. So what we have is we have a matrix with the coefficients. These are the coefficients on the x's, these are the coefficients on the y's, and then we have our variables x and y. Okay, so we have the coefficients, and then we have the variables. Now that's only half our equation, equals, and then we need the constants, 3, 8. So that's how we set it up. Now I want you to think, let's go back to a normal equation that you've been solving for years. 2x plus 3 equals 15. To solve this, instead of to undo the adding 3, you would do the opposite, subtracting 3. That's because adding 3 and subtracting 3 are inverses. And that would give us 2x equals 12. Then you have 2 times x, you would divide by 2, because multiplying by 2 and dividing by 2 are inverses. And we would not have the solution x equals 6. So this is just a little side note to remind you that all the times you've been solving equations, you have been using inverses, okay? So we are going to need the inverse of this matrix. Well, lucky for us, that's the matrix we had in example 2. So we already found the inverse. So we are now, using our work from example 2, we're going to multiply both sides of the equation by the inverse matrix. And this inverse matrix must go first on both sides. And then we have this 1, 2, 1, 3 times x, y equals, now don't forget the inverse comes first, because if you put it in the other order, you won't be able to multiply, times the matrix 3, 8. Okay, so now we should know that if we multiply these, what should we get? A matrix times its inverse in either order. Whether the inverse is first or the function is first, doesn't matter. A matrix times its inverse is the identity matrix. And we could go through all the work and we could do that multiplication. So that means this is going to give us 1, 0, 0, 1. And we still have times x, y. And on the other side, why don't we go ahead and start doing some multiplication here? So we're going to take our rows from the first. So my first row is 3 times something plus negative 1 times something. And our column is 3, 8. Row 2 is negative 2 times something plus 1 times something. And our something is still 3, 8. Okay. Then we need to multiply the identity times a matrix. Now, I'm going to come over here and I'm actually going to do that. 1, 0, 0, 1 times xy. And this is just to prove something to you. If we take that first row, we're going to have 1 times something plus 0 times something, and our somethings are the x and the y. The second row is 0 times something plus 1 times something, and our somethings are the column x, y. I'm out of rows, I'm out of columns, and this is going to give us x plus 0, or just x, and this is going to give us 0 plus y, which is just y. Now we should know that answer is xy already because we know that the identity matrix times another matrix is that matrix. So that means this work over here, you do not have to show, okay? Do not have to show. All right, now on the other side, we have a little bit of arithmetic here going on. We got 3 times 3 is 9, minus 8. We've got negative 6 plus 8, which means one more step. And we can say that xy equals 9 minus 8 is 1, and negative 6 plus 8 is 2. And lo and behold, here is our solution where x is 1 and y is 2. And that's the same solution we got to the initial problem in the video. So this is the same answer as example 1. The difference is, in example 1, we wrote the answer as an ordered pair, and here we're writing the answer in a matrix. All right, awesome. Okay, so here we have a little graphic to remind us that when we want to solve the system of equations using a matrix equation, we take the coefficients on the x's is the first column. The 2 and the negative 1. That's where this column came from. Then we have in the second column the coefficients on the y's. That's the invisible 1 and the negative 3. That's where this column came from. Times our variable matrix equals our constant matrix. Okay, so you have to have your x's, your y's, and your constants lined up. And your constants need to be the only thing on the other side of the equal sign. Okay? Now, in order to solve this, the first thing we need to do is we need to find the inverse of the coefficient matrix. So our coefficient matrix, remember, over here, was the 2, negative 1, 1, negative 3. So we need to find the inverse of that. So the first step, we find the determinant of 2, negative 1, 1, negative 3. We multiply on the downward diagonal. 2 times negative 3 is negative 6. Minus, we multiply on the upward diagonal. Negative 1 times 1 is a negative 1. So that's going to give us negative 5. Okay. Now for the inverse, it's 1 over negative 5. We keep the matrix. It's going to be a 2 by 2. But on this first diagonal, we switch the numbers, negative 3 and 2. And then on this diagonal, we negate them and we change the sign. So now we multiply by that scalar, and we're going to have negative 1 over negative 5 times negative 3 is positive 3/5. 1 over negative 5 times 1 is a negative 1/5. Negative 1/5 times negative 1 is a positive 1/5. Negative 1/5 times 2 is a negative 2/5. And there's our inverse. I just want to hold that so we can see it, because now what we need to do is we need to multiply both sides of our matrix equation by that inverse. So we're going to have 3/5, negative 1/5, 1/5, negative 2/5 times the coefficient matrix, 2, negative 1, 1, negative 3, times the variable matrix equals the inverse matrix. And remember, order is important. The inverse has to be first on both sides of the equal sign. So it was 3/5, negative 1/5, positive 1/5, negative 2/5 times our constant matrix, 6, 2. Now we have a little bit of work to do. So the first thing is we know that a matrix times its inverse is always the identity. So the product of these two matrices is 1, 0, 0, 1 times, we still have the variable matrix xy equals, now we need to do a little bit of work on the other side here. First row, 3/5 times something plus 1/5 times something, and our somethings are the 6 and the 2. In row 2, we have negative 1/5 times something, minus 2/5 times something, and our somethings are the column 6, 2. All right, now we also know that the identity matrix times xy is going to give us xy. And on the other side, we've got a little bit of arithmetic to do. So we're going to have 3/5 times 6, that's 18/5, plus 2/5, and then we're going to have negative 6/5 minus 4/5. Now 18 plus 2 is 20 over 5. Oh, I forgot to bring down my variable matrix. And 20 over 5, by the way, 20 divided by 5 is 4. And then on the bottom here, we have negative 6/5 minus 4/5. That's negative 10/5. And negative 10 divided by 5 is negative 2. And we now have our solution to the system of equations. We know that x is 4 and y is negative 2. All right, guys, so we learned a new method for solving a system of equations. And yes, I am making you show out all the work that is here. But once we've mastered this, I'll have another little trick to show you to help you make this a little faster. But here we go. So when you have a system of equations, you're going to write the coefficient matrix times the variable matrix equals the constant matrix, and you're going to multiply both sides by the inverse of the coefficient matrix. Okay, guys, have a great day. I'll see you soon. Bye.